Let's solve this challenging integral. We need to integrate dx over the square root of x plus 1 minus the square root of x. The key to solving this integral is to rationalize the denominator. We'll multiply both numerator and denominator by the conjugate of the denominator, which is square root of x plus 1 plus square root of x. The denominator simplifies nicely. Let's see how. When we multiply these terms, we get x plus 1 minus x, which equals 1. Therefore, our integral simplifies to the integral of square root of x plus 1 plus square root of x dx. We can split this into two separate integrals, the integral of square root of x plus 1 dx plus the integral of square root of x dx. Let's solve the first integral. For square root of x plus 1, we can use the substitution u equals x plus 1. This gives us 2/3 u to the 3/2 power, which becomes 2/3 times quantity x plus 1 to the 3/2 power. For the second integral, we directly integrate square root of x to get 2/3 x to the 3/2 power. Combining these results and adding our constant of integration c, we get 2/3 times quantity x plus 1 to the 3/2 power plus 2/3 x to the 3/2 power plus c. Comparing this with the given form a times quantity x plus 1 times square root of x plus 1 plus bx times square root of x plus c, we can conclude that a equals 2/3, b equals 2/3, and c is absorbed into our constant of integration. And there we have it. We've solved this complex integral through careful rationalization and integration techniques.